Let's dive right into this explainer. You know, we hear so much buzz lately about AI agents taking over the world, right? But the actual engineering behind them, it can often feel like this massive, impenetrable black box. Well, today, we're prying that box wide open. In under 15 minutes, we are going to build a highly capable, custom-tooled AI research assistant in Python using LangChain. We'll see exactly how to stitch together large language models, structured data, and custom tools to create an autonomous assistant that actually does the heavy lifting for you. It's a total game changer for how you handle repetitive digital tasks.
Here's our roadmap for the build. To keep this technical journey crystal clear, we're breaking the anatomy of an agent down into 5 straightforward milestones: the environment, the brain, the rules of engagement, the hands, and finally, the spark of life. Let's jump right in.
Milestone 1. The environment. Basically setting up the operating room.
Think of this step as prepping a clean, sterile operating room before a major surgery. You'll want Python 3.10 or above and a solid code editor like VS Code ready to go. So we start by creating an isolated virtual environment, a walled garden for our project, just using the standard python-m venv command. This is an absolute lifesaver, guys, because it keeps our workspace completely conflict-free. Once that's activated, we just pass our requirements text file into a pip install command. That pulls down the exact frameworks we need, primarily LangChain, Pydantic, and our search utilities, without messing up your system's global Python installation. It keeps the foundation incredibly solid. Now, to keep things organized as we build, we're separating our logic into 3 essential files. Main.py is where our core agent logic will eventually live. Tools.py acts as a neat little toolbox for our external actions, just to keep the main file from getting cluttered. And, crucially, we have a .env file. This acts as a secure vault for our API credentials. Because, let's be real, you never want to hard-code API keys directly into your scripts, unless, you enjoy the thrill of accidentally pushing them to GitHub for the whole world to exploit. We'll just use a standard package to load those secure keys behind the scenes when the code runs.
Moving on to milestone 2. The brain. This is where we give your agent its core intelligence.
The brain of our operation is, of course, the large language model. It's the core reasoning engine that ultimately decides what needs to be done based on whatever prompt you throw at it. And the brilliant thing about using LangChain here is just how modular it makes this step. Whether you decide to go with OpenAI's GPT-4o Mini or Anthropic's Claude 3.5 Sonnet, the code structure is almost completely identical. You simply import Chat OpenAI or Chat Anthropic, load your secure API key from that environment file we just talked about, and specify the model version. It gives us the ultimate flexibility to just swap out brains on the fly. If we want to test the different models' reasoning, or if we suddenly hit unexpected rate limits, boom, we just switch it out.
Milestone 3. The rules of engagement. It's all about structuring the output.
Listen, if we just ran our brain right now, it would spit out massive, unpredictable walls of raw text. Now, that's totally fine for a casual chatbot, but it is an absolute nightmare if you're trying to build reliable software. We need predictability, and we achieve this by using a Pydantic class to force the LLM's messy output into a very strict Python data schema. We are explicitly defining our expectations here. We say, I want a topic, and it must be a string. I want sources, and they absolutely must be a list of strings. This means later in our code, we can seamlessly pull out response.topic or response.sources and use those specific pieces of data instantly. No writing messy, fragile code to parse through paragraphs of rambling text.
But how do we ensure the LLM actually obeys this schema? Well, we use a prompt template. Think of an LLM as a brilliant but easily distracted intern. We take that Pydantic model we just built, convert it into format instructions, and inject it straight into the system message right alongside the user's query. We're explicitly telling the agent, you are a research assistant and you must wrap your output in this exact format, providing absolutely no other text. This template becomes the unshakable rulebook our agent has to follow, guaranteeing our software doesn't break down the line.
Next up, milestone 4, the hands. This is where we equip the agent with tools.
Because a brain locked in a box isn't an agent, right? It's just a chatbot. To make it a true agent, it literally needs hands to interact with the outside world. So we're giving our agent an impressive arsenal. LangChain's community utilities let us plug in Wikipedia and DuckDuckGo right out of the box, completely free, without even needing to manage an API key for them. How cool is that? But the real magic happens when we want the agent to do something totally custom, like natively writing its final research findings to a local text file right on your hard drive.
Now, it's really easy to overthink this, but a tool in LangChain is truly just a basic Python function with a description attached to it. That's literally it. It's not some deeply complex neural network operation. If you can write a standard Python function, you can give your AI agent a brand new physical capability in the digital world. The description is vital, though, because the LLM actually reads that description to figure out if it needs to use your tool to solve whatever prompt the user just gave it. Building our custom text-saving tool happens in 3 really simple steps. First, you define your standard Python function with typed parameters so the model knows exactly what kind of data it's handing over. Next, you import LangChain's tool class. And finally, you just wrap your function inside that class, assigning it a spaceless name, something like save_text_to_file, and a crystal clear description of what it accomplishes. Just like that, your agent is armed and ready to trigger your custom code autonomously whenever a task requires it.
Finally, milestone 5, the spark of life. Let's bring this agent to life.
Up until now, we've basically just had interesting pieces sitting on a workbench. To ignite the spark, we use LangChain's create_tool_calling_agent function to combine our LLM brain, our strict Pydantic rules, and our tools. We then wrap the whole shebang in an agent executor. When we input a query like research Southeast Asia population and save to a file, the agent takes over completely. Notice you didn't write a linear step-by-step script here, you just gave it an end goal. The brain analyzes the prompt, realizes it needs demographic data, autonomously fires off the web searches, gathers the info, formats it perfectly to our strict rules, and finally triggers the save tool to complete the loop. If you set verbose to true in your code, you can literally watch this incredible thought process stream across your terminal like the Matrix. It's awesome. And here is the ultimate payoff. A beautifully formatted text file automatically generated and saved directly to our local directory with absolutely zero manual intervention. We successfully tamed the raw chaos of an LLM. We have our exact timestamp, our specific topic string, our clean summary, and our exact list of sources. Because we strictly demanded structured output through our rules of engagement, we get a pristine, highly predictable result every single time. It perfectly bridges the gap between conversational AI and reliable software engineering.
So you now possess the blueprint to build a fully working AI agent in Python in just about 15 minutes. We set up a sterile environment, harnessed a powerful language model, mandated structured outputs, and armed it with real-world tools. This exact framework is the foundation for automating almost any repetitive digital task you can possibly think of. So, taking a hard look at your own daily workflow, what tedious tasks are currently draining your time, and what custom tools are you going to build for your agent to finally take them off your plate?